Hey guys, welcome to another lesson here in Science 14. This is Mr. Adamson, and we are going to talk about the fascinating world of microscopes. So sit back, relax, because this is going to be super entertaining. So we're going to talk about two specific kinds of microscopes. The first one we're going to talk about here, you can see under where the cursor is going, is a compound microscope, and that's a little picture there of a compound microscope. That's what we have in the school here. Couple interesting points about them, especially when you're doing your assessments on terms. They use light to illuminate, so you can see a little light down here, and they magnify something 400 to 1,000 times its normal size. The other type of microscopes that we're going to talk about are electron microscopes, and these use beams of electrons, just as the name says there. They can magnify 600,000 times the normal size. And there are specifically two types of electron microscopes we're going to talk about. There's the transmission electron microscope, or better known as TEM, and the scanning electron microscope, better known as SEM. Now, specifically the compound microscope here, we're going to go over its parts. You're going to have to know some of these parts. And specifically, you see it's labeled. So if we start with A, you can see A is right here. This is the light source, so it's a bulb of reflection from a mirror, and it sends light up through the object being viewed, so you can see the object a lot easier. Next part is B, the diaphragm. This controls the amount of light reaching the object, and that's right here. The stage is C. That's where you put the microscope slide on. D, the stage clips. That's what holds the slides down. E, the objective lens. These magnify the images. Now you're going to have objective lenses that are medium power, or low power, medium power, and high power. Low power usually magnifies something 40 times. The medium power, they magnify something usually 100 times. And the high power objective mainly magnifies something 100 times. If you look at F, this is the tube right up here, and it holds the eyepiece and the objective lenses at the correct working distance from each other, so you can actually see something when you're looking into it. G is the eyepiece, so right up here, some only have one, some have two, this one has two. It has a lens that enlarges the image from the objective lens, and this usually is 10 times what's actually on the slide. Now H, right over here, this is the coarse adjustment knob, and this is what moves the stage up and down, and you can physically see it really move. Now you only want to use the coarse adjustment when you're on the low power objective lens. If you use it on the medium or high power, lots of times you'll bring the stage up too high and you'll crack what you're looking at. So if you have a slide right there, you'll probably crack the slide because it's going to push against it. I, so right here, this is the fine adjustment knob, brings the image into clear focus. It's used with medium power and high power objective lenses because it's only going to move slightly. And then the last one, J, that is the arm, so right here where the cursor is moving, and the base. And that's where you're going to hold, and the base is obviously what that sits on. So anyways, that is the compound microscope. Now, going back to electron microscopes, again, we said we had the transmission electron microscope, the TEM. So it focuses a beam of electrons at a very thin slice of object under study. Now, the specimen is covered in chemicals, and it's inserted into a vacuum-sealed part of a microscope. Now, big thing about the transmission electron microscope, the specimen must be dead that you're looking at. And I mean, obviously it is because you're covering it with chemicals, and it's in a vacuum-sealed part of a microscope, no air. Then the next one is the transmission electron microscope, or the SEM, and a beam of electrons is passed over the specimen being observed. So a 3D image of the specimen is produced on a computer screen, and this is where you can look at living organisms. You can see them move. I mean, if you're going to look at bacteria and things like that, that's really cool. So anyways, that's a little bit about microscopes. Hope you were just as excited about learning about them as I was. And until next time, check you later.